Hi everyone, let's take a look at the following example. Given that vector A equals to vector x plus 2 times vector y and vector B equals to 2 times vector x plus 3 times vector y. Part A, express the vector x in terms of vector A and vector B. Step number 1, copy the given. Vector A equals to vector x plus 2 times vector y. Underneath, copy vector b equals to 2 times vector x plus 3 times vector y. In order to isolate for vector x in terms of vector a and vector b, we need to eliminate vector y. So again, if you think about grade 10 academic math, you can call these equation 1 and 2. Think about the common denominator 2 and 3, or greatest common factor. So when you think about 2 and 3, the common number that I'm thinking about is 6. So all we're going to do is we're going to multiply the first equation by 3. This means it's going to give you 3 times a, which is 3a, 3 times x, which is going to be 3x, 3 times 2y, which is going to be 6y. Likewise, if I look at the second equation, I'm going to multiply this by 2. 2 times b is going to be 2b. 2 times 2 is going to be 4x. And of course, 2 times 3y is going to be positive 6y. Now, remember, there are two skills that you've learned back in grade 10. These are, if they are the same, you are going to subtract. And if they're opposites, this means you have to add. So what I mean is, if you look at these two terms, positive 6x and positive 6x, these are the same. And because they're the same, you are going to subtract. So again, I'm going to subtract them. I'm going to put a circle around this. Let's go back to the same color. On the left-hand side, it's going to be 3a minus 2b. And of course, when I say a, I mean vector a. When I say b, I imply vector b. On the right-hand side, 3x plus 4x is going to be 7x. And of course, 6y minus 6y is going to be 0. Let's go back one step. I just realized I am not subtracting. One more time. See, mistakes are our friends. So 3x minus 4x is going to be negative x. Now we can isolate for x. Again, we'll zoom in for you. Give you this optical illusion. It's a little bit simpler when I'm really just zooming in. The opposite of multiplying by -1 is divide by -1. So vector x equals to negative 3 times vector a plus 2 times vector b. Let's keep going. Part B. Express the vector y in terms of vector a and vector b. So same idea, right? If I use a different color, I'm going to continue from this part right here. So again, what we talked about was part A, which was here. And now we're going to do part B. Now, our goal in order to isolate for vector y is to eliminate x. So again, if I look at this, and maybe I'll just do it one more time just to be clear. So I'm going to copy this again. I'm going to call this equation 1, call this equation number 2. The only difference is we need to eliminate x. Now this is a lot simpler because if you think about this, there's 1x and there's 2x. So the common number I'm thinking about is going to be 2. All I'm going to do is multiply the first equation by 2. So I'm going to write down number 1, multiply by 2. 2 times a is going to give you 2a. 2 times x is going to be 2x. And of course, 2 times 2y is going to be 4y. I can express this, or I can name this as 1a. Again, notice these are the same. When they are the same, you will subtract. So if you look at the first column, vector b minus 2 times vector a equals to 2x minus itself is going to be 0. 3y, or 3 times vector y, minus 4 times vector y is going to be negative vector y. Again, here comes the optical illusion. I'm just zooming in to give you the impression that it's a little bit simpler, but I'm just really zooming in. The opposite of multiplying by -1 is to divide by -1. So y equals to negative vector b plus 2 times vector a. Now, before I continue, I would like you to try parts C and D. And of course, once you're done and you press play again, I'll be here. Welcome back, everybody. Let's keep going. So I'm just going to color code this for you. I'm going to use a brand new color for part C, and I'm going to write it right here. So I'm going to increase the font size. Part C. Express the vector B in terms of vector y and vector a. So if you think about this, right now vector b equals to 2 times vector x plus 3 times vector y. But the goal is to express this only in terms of vector y and vector a. So we don't want it in terms of vector x. So we go back to the given, a equals to x plus 2y, and all we're going to do is isolate for x. So again, the opposite of adding 2 times vector y is to subtract. So you can write down a minus 2y equals to x, or you can say x equals to a minus 2y. I'm going to put a box around this. I'm going to plug it back in, and look what happens. If I plug it back in into here, let's try again. This implies vector b equals to 2 times vector a minus 2 times vector y plus 3 times vector y. And if you collect like terms, this is going to be 2 times a minus 4 times y plus 3 times y, which means b equals to 2a minus y. And again, that's how you express vector b in terms of vector y and vector a. Part D. Express the vector b in terms of vector x and vector y. So we're going to finish strong with a fourth color. Let's say we write this in black. Okay, here we go. So if you think about the given right now, again, b equals to 2x plus 3 times y, and that's going to be part D. Now our goal is to express this only in terms of vector x and vector a. This means we don't want y. So we go back, a equals to x plus 2y, and we're going to isolate for y. So let's isolate for y. The opposite of adding x is to subtract x. So vector a minus x equals to 2y. The opposite of multiplying by 2 is to divide by 2. So vector y equals to a minus x divided by 2. Again, I'm going to put a box around this. I'm going to plug it back to here, and look what happens. Now, when I express vector b, this equals to 2x plus 3 times in brackets, vector a minus vector x divided by 2. Now, all you have to do is expand this. 2x plus 3a divided by 2 minus 3x divided by 2. One more step. Vector b equals to, let's highlight these terms. So again, if I think about 2x minus 1.5x, again, you can do some mental math, or if you want to use a calculator, that's fine. 2 minus 1.5 is 0.5, or half, times vector x plus 3 over 2 vector a. Now, of course, one person's going to say, can I express this in decimals? So if you wrote it as 0.5x plus 1.5 times vector a, that is perfectly fine. I hope this makes sense.